Good morning, students. This is Ravi sir from Devashia International Public School. Today we'll be starting with a chapter of geometry, that is Introduction to Euclid's Geometry. With this chapter, we will start with the geometry section. So before we start with this chapter, let us first have some look at some of the very interesting facts about geometry. Now, how this geometry was developed from ancient times, we'll look into that. Now we see geometry comes from two Greek words, that is geo, which means earth, and metrion, which means to measure. The geometry appears to have been originated from the need for measuring lands. This branch of geometry was studied in every ancient civilization. For example, Egyptian civilization, Babylonian, Chinese, Indian civilization. Apart from that, even Greek civilization and even Incas as well. Now, the people of all these civilizations faced many practical problems for which they required development of geometry. For example, whenever there was a flood in the river Nile in Egypt, it used to wipe out the boundaries between the adjoining fields of the farmers. So, after such flood, the boundaries had to be redrawn. So, for this purpose, the Egyptians developed a number of techniques and rules for calculating simple areas and for construction for simple constructions as well. Okay, so and the knowledge of geometry was also used for calculating the volume of granaries and even construction for canals and pyramids. The development of geometry was also done in Indian subcontinent as well. For example, the two very famous cities of Harappa and Mohenjo-daro, that is Indus Valley civilization, there was a excavation, and we found out that there was a huge work done in geometry as well. For example, the cities were very highly organized, the societies were very highly organized, the cities were very highly developed and well planned, the roads used to be parallel to each other, and apart from that, the drainage system was also underground. All these things shows that the people of these civilizations were very skilled in mensuration and arithmetic. The bricks which they used for the constructions had the ratio of length is to breadth is to height, that is 4:2:1. Apart from that, there was a very famous book which was written, that is Sulba Sutra. Now this is actually a manual of different geometric constructions. Now, geometry originated in the Vedic period from the construction of altars. Altars, actually in Hindi we call it as a Vedis, or you can call it as a Havan Kund for better understanding. So these used to be of different shapes. For example, circular altars and the square altars were used for the home rituals, and even triangular, rectangular and trapezium altars, Havan Kund, were actually also used for the public worship as well. Now apart from that, students, Sri Yantra, we already know Sri Yantra, right? That it is actually, it consists of 9 interwoven isosceles triangles which are arranged in such a way that it produces 43 subsidiary triangles. Now students, all these work shows that the work of geometry was developed in every field, every civilization, but it was very unsystematic manner. Now first of all, in the Greek civilization, the people laid emphasis on reasoning behind every construction. Okay, these people were interested in establishing the truth of the statement which they discovered by deductive reasoning. Now it is said that the first statement which was proven by Thales, a Greek mathematician, for the first time he proved that a statement, that is a circle is actually bisected by its diameter. So this was for the first time in the history of geometry that some statement was actually proven by Thales. He was a Greek mathematician. After that, there was a mathematician and a teacher whose name was Euclid. Okay, he was from Alexandria, from Egypt. Okay, actually what he did is he compiled and he arranged all these works and all the facts about geometry and arranged in a very famous treaty, and he called this as elements. Now he divided elements into 13 different chapters, and each chapter he called it as a book. Okay students? Now now students, if we consider the three steps from solid to point, that is going from solid, then surface, then line, then point. Actually solid is three-dimensional, that means it has three dimensions, that is length, breadth and height. Surface, it has two dimensions, that is length and breadth, there is no height. And line, it has length, only one dimension, it has only length, there is no breadth, there is no height, okay. And point, it is actually non-dimensional. So actually Euclid, he summarized all of his statements into definitions. So in total he gave 23 definitions in the book of his element, book 1 of his element. So let us just check which are these definitions given by Euclid. The first one, a point is that which has no part. A point is that which has no part. A line is a breadthless length. Okay, the ends of the lines are point. The straight line is a line which lies evenly with the point itself. Okay, the surface is that which has length and breadth only. The edge of the surface are actually lines. The plane surface is a surface which lies evenly with the straight lines on itself. Now, when we read all these definitions, students, we come across some of the terms like the part, breadth, length, evenly. Now, look at this first definition. The point is that which has no part. But here we need to clarify the meaning of part. That means we need to define the part also. So what is a part actually? Anything which occupies some area is known as part. Now again students, we need to define area now. So if we keep on defining such terms, we will get a huge number of the chain of different definitions. So finally what mathematicians did is they agreed to leave some of the geometric terms undefined. Okay, so there is no definitions for such kind of terms. Now after that, students, the Euclid actually he assumed some of the properties without any proof. Fine. So these assumptions, he divided these assumptions into two different types. Okay, the thing which is specific to geometry, right? The term which is actually only used for geometry, he used such assumptions, that is as postulate. And the other type which is not specific to geometry and it is used everywhere or throughout mathematics, he called such assumptions as axioms. So assumptions, he gave two types, one is postulate and the other is axioms. Postulate is specific to geometry and axioms are those statements or those assumptions which are used throughout mathematics. Okay. Okay students, now we will be discussing some of the axioms which are given by Euclid. Now first one, things which are equal to same things are equal to one another. Okay, so meaning of the first axiom, let's just read it once again. Things which are equal to the same thing are equal to one another. Meaning of this first axiom is actually it refers to some kind of magnitude, students, and it is always applied to the plane figure. Okay, so you see, if for example area of a triangle is equal to area of a rectangle and area of a rectangle is equal to area of a square, that means area of a triangle is equal to the area of the square. Okay, this is just like if A is equal to B and B is equal to C, then A and is equal to C. Okay, now second and third axiom, it says if equals are added to equals, then the whole are equal. And third one, if equals are subtracted from equals, the remainders are equal. The meaning of the second and the third axiom is actually magnitudes of same kind can be compared and they can be added. That means magnitude of same kind can be operated. Okay, for example, lines cannot be added to rectangle because these are not having the same magnitude. Okay, and again angles cannot be added to the pentagon. Okay, they are uncomparable, right? There is no comparison between them, so they cannot be operated, they cannot be compared and they cannot be added. Okay, now fourth axiom, it says things which coincide with one another are equal to one another. Okay, the meaning of this axiom is actually, if two things are identical, if two things are identical, then they are actually equal. For example, it also gives the justification of principle of superposition. For example, just look at our palm. Okay, they both are identical. Okay, and they can be actually superimposed on each other. When they are superimposed on each other, then they will do the proper alignment. Okay, so this is the meaning. If two things are identical, then they are equal. Okay, now fifth axiom, the whole is greater than the part. The whole is greater than the part. Fourth axiom, it gives the definition. Fifth axiom gives the definition of greater than. For example, if there is some quantity B, it is a part of A. There is some quantity B which is a part of A, then A can be written as sum of B and some third quantity C. For example, symbolically it can be written as, if A is greater than B, then there is some third quantity C which can be written as A is equal to B plus C. Okay. Now we will discuss Euclid's 5 postulates. Now, as we already know what are postulates, postulates are assumptions, okay, given by Euclid. Now, first postulate, it says that a straight line may be drawn from any one point to any other point. Once again, let's just read. A straight line may be drawn from any one point to any other point. What does this mean? It means that at least one straight line passes through two distinct points. Okay, now but the above statement does not say that there cannot be more than one such line. Okay, it does not mention that. And apart from that, in his work, Euclid has frequently assumed, without mentioning, that there is a unique line joining two distinct points. Okay, so the above result is actually taken as an axiom. Okay, this is the axiom. Given two distinct points, there is a unique line that passes through them. Given two distinct points, for example, let's take these are 2 points P and Q. These points are distinct points, that means they are separate points. There is number of lines passing through point P, and there are number of lines passing through Q also. But there is one question, students: how many number of lines passing through P are also passing through Q? Obviously, there is only one line which passes through P and Q, and that line is line PQ. Okay, one more question: how many number of lines passing through Q also passes through P? Also, there is only one line that passes through P and Q both, and that is again P and Q. Okay, so there is only one line which can pass through two distinct points. Okay, so this statement above is self-evident. That is the reason, students, this statement or this result is actually taken as an axiom. Okay, what are axioms? These are such statements which are taken without any proof. We don't have to give any kind of proof for that because they are self-evident. Okay. Euclid's second postulate, it says that a terminated line can be produced indefinitely. Now students, what we call today as a line segment, actually Euclid's called it as a terminated line. So whenever there is a such term in Euclid's postulate like terminated line, we have to understand it as a line segment. So let's just read it once again. A terminated line can be produced indefinitely. So what does that mean? It means the line segment, for example, this is a line segment AB can be extended. This line segment can be extended on either side, on both the side, to form a line. Okay, it has a very simple meaning that any line segment, for example, line segment AB can be extended on both the side to form a line. Postulate number 3, what does it say? A circle can be drawn with any center and any radius, right? A circle can be drawn with any center. For example, if I am putting a point over here and I am telling this point as A, then circle can be drawn from this point. Then at that point the center will be A, okay? And it can be drawn of any radius. We can take the radius as 4 centimeter or 5 centimeter, okay? Postulate number 4, it says right angles are equal to one another. Okay, all right angles are actually equal to one another because all right angles are actually 90 degree only. We already know that. So all the right angles are actually equal to one another. Postulate number 5, it says if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. Now see, postulate number 5 is actually very lengthy and bit complicated. Let's understand this. Now it says that if there is one line, let's say line PQ, it falls on two straight lines. One is AB and the other is CD. Okay? In that case, the sum of interior angles, that is 1 and 2, will be less than 180 degree on the left hand side of line PQ. So in such a case, the line AB and CD will eventually intersect each other on the left hand side of PQ if they are produced further. Okay, fine. Now the statements which were proved by Euclid are actually called propositions or theorems. Okay, in total he deduced 465 postulates. He deduced 465 theorems. Okay, students, today we will be doing two examples which are based on Euclid's axiom and Euclid's postulate. So first example, it says that if A, B and C are 3 points on a line, okay, and B lies between A and C, as we can see 3 points A, B and C are on the line and point B lies between A and C, then we need to prove that AB plus BC is equal to AC. That means AB plus BC is equal to AC. Okay, so we begin our solution by saying actually AC coincides with AB plus BC. Okay, the whole AC segment coincides with AB plus BC. So from axiom 4, which says that things which coincides with one another are equal to one another. Okay, from this we conclude or deduce that AB plus BC is equal to AC. AB plus BC is equal to AC. We have one more example here which says that prove that an equilateral triangle can be constructed on any given line segment. It says that an equilateral triangle can be constructed on any given line segment. It says on any given line segment. So we have taken any line segment, let's say AB. Here before proving it, we need to do some constructions. So what we have done is from line segment AB, we are doing one construction using Euclid's postulate 3. Euclid's postulate 3 says that we can draw a circle with any center and any radius. So first of all, we are drawing a circle with point A as center and AB as radius. Okay, this is the circle. And we are drawing another circle with point B as center and BA as radius. We are drawing another circle. Both the circle actually coincides at a point, meet at a point, let's say C. Okay, so this is the construction. We join AC and BC. So we have triangle ABC. Now we have construction, we have done the construction. Now we need to prove that AB is equal to AC is equal to AC. That is what we need to prove, because we need to prove that it is an equilateral triangle. So if we say AB is equal to B, AC is equal to BC, that is all the three sides of a triangle are equal, we can say that it is an equilateral triangle. So we begin our proof by saying that AB is equal to AC. AB is equal to AC because both AB and AC are the radii of the same circle. Again, we say AB is equal to BC. AB is equal to BC because AB or BA and BC are actually radii of same circle. Okay, so from result 1 and 2 and Euclid's axiom 4, which says things which are equal to the same thing are equal to one another. Things which are equal to the same thing are equal to one another. From that we deduce AB is equal to AC is equal to BC. That means we have proven all the three sides equal, and therefore we can say that triangle ABC is an equilateral triangle. Now we begin with the theorem 5.1, which says that two distinct lines cannot have more than one point in common. Two distinct lines, that means two separate lines, cannot have more than one point in common. Okay, so what we need to prove here is actually lines L and M have just only one point in common. These are two lines L and M, they have only one point in common. That is what we need to prove. Okay, now we are given with lines L and M. Now we begin our proof with a contradiction. We assume something. Suppose there are two lines which intersect at two distinct points. There are two lines and they intersect at two distinct points, suppose P and Q. Okay, so that means what? That means we have two lines which passes through two distinct points, say P and Q. But you know, students, this assumption, this contradiction actually clashes with the axiom, which says that only one line can pass through two distinct points. There is only one line which can pass through two distinct points. So our previous assumption, this assumption is wrong. So we conclude by saying that two distinct lines cannot have more than one point in common. Okay, students, so in this chapter we studied some of the basic things about geometry, and we also studied some definitions of Euclid. We studied some axioms and postulates of Euclid. We did some of the examples of proving using axioms and postulates, and apart from that we did a theorem 5.1. okay, so this is it. In our next video we will be starting with the first exercise. Okay, so till then keep practicing and this will improve you a lot. Thank you.